So when you're dealing with quadratic functions, you may have noticed that it's a lot easier to understand them when they're written in vertex form. Here we have an example of a quadratic function, but it's not currently in vertex form. Right now it's in standard form, right? So our instructions say to write f of x in the form a times the quantity x minus h squared plus k. That is actually vertex form. In order to transform the function that we're giving into vertex form, we're going to focus on these first two terms here. So I'll just take this plus 21 and move it off to the right just a little bit. So we're looking at these first two terms and we want to complete the square. In other words, what can I add to these two terms in order to make them a perfect square trinomial, right? So there's some mystery number that I'm going to add right here that's going to make these two terms, along with the new term, a perfect square trinomial. The way I find that third term, the mystery term, is by taking the linear coefficient. In this case, that's the number in front of the x. I'm going to multiply it by 1/2 every single time. And I'll take that result and square it. So negative 10 times 1/2, and that's a multiplication symbol right there. Negative 10 times 1/2 gives me negative 5. And negative 5 squared is 25. So this tells me that if I take these first two terms, and my first two terms are x squared minus 10x, and I add a 25, the result is a perfect square trinomial. But I can't just add 25 to an expression, because if I just add 25, what happens is I actually change the expression, and now my function isn't the same as it was at the very beginning. So then to balance out this addition of 25, I have to also subtract 25. Right? So I'm adding 25 and subtracting 25. That's a common trick in mathematics. You can multiply by 1 and add 0, and we just added 0 in this case. At any rate, now I have two tasks. My first task is to factor this trinomial. So then I need to think of two numbers whose product is positive 25 and whose sum is negative 10. And we know that negative 5 and negative 5 will do the trick. So as it turns out then, this perfect square trinomial is x minus 5 quantity squared. If you ever get in a bind and you can't think of the number that goes in here with this x, you can always just look at your scratch work, right? So this negative 5, whoops, there we go. That negative 5 right there is always going to match this negative 5. Right? That number there is always going to match the number on the right that I just highlighted. Okay, so let's finish this problem. Negative 25 plus 21 is negative 4. So there we have it. F of x is equal to the quantity of x minus 5 squared minus 4. And we've done it. We've written f of x in vertex form.